All right, so we're multiplying complex numbers. There's one big thing that you have to do. First thing is you're going to treat I just like any other variable. And we'll say unless you get I squared. Okay, if we were doing the full method, if we were doing distributed property, all those other things we were going to do, it's all the same thing. The only thing you have to worry about doing anything different is if you get I squared. If you get I squared, you're going to replace I squared with -1. Okay, so as far as everything else goes, that's it. That's the only thing that you have to do that's the least little bit different when it comes off of it. It's just that one thing that anytime you get I squared, you're going to replace that with a -1. All right, so let's show you some examples on this thing so you can kind of see what's happening here. So let's say we have 6I times 2 minus 3I. So we'll start off with just a plain distributed property here. So we're going to do 6I times 2 and 6I times -3I. So that is 12I. 6 times 3 is 18. And I guess the biggest thing you have to remember, because you didn't do a lot of this in geometry, so for some of y'all it's been a couple of years, when you do I times I, that is when you will get I squared. Okay, and you're going to take out the I squared, replace it with -1. So it really makes it 12I plus 18. And they should tell you to write these answers in A plus BI or complex form, so you just got to reverse the order on this one. Put the 18 first, and then put the 12I second, and then you're good to go. Okay, so distributed property, it's the exact same thing you normally do again, but if you happen to get an I squared, you've got to take that part out and replace it there. Example 2, example 3. For these two, we're going to go back through and show you the full method. So we're going to do 4 minus 3I times 5 plus I. Okay, so going through and doing the full method. Now, the biggest thing on this one is sometimes people forget when they're, especially when you put these together and you're adding and subtracting and doing all the stuff, is that when you're going to do the full method is when it's all together, because sometimes people will try to do addition or subtraction on this one, but if there's not a sign in the middle, just remember it's basically multiplication. So we're going to do 4 times 5 and 4 times I. So 4 times 5 is 20. 4 times I is just 4I. And then we're going to do -3I times 5 and -3I times I. So we're going to -15I. And for this one again, we do I times I, that will make it I squared. All right, and just like when you did the full method before, when we're doing, if you had X or Y, whatever variable you're working with, you always have some parts you can clean up. The 20 is good. Let's scoot down just a little bit. You can take these two numbers, though, and add or subtract them together. So it's 4 minus 15, so that's a -11I. And again, same thing with this one. You have the I squared, replace it with -1. So it's -3 times -1. That'll make that a +3. Okay, and then the last thing that you'll do is now you've got 20 plus 3, so you can take those two things and add it together and get it 23, and then minus the 11I. Okay, and let me show you one more full method just so we've got a little practice with it. Sorry, example 3. All right, so for this one, let's do 5 plus 2I times 5 minus 2I. Okay, so first thing is we've got 5 times 5 for 25. 5 times negative 2, we make it negative 10i. 2 times 5, and then 2 times 2. So we've got 2i times 5 for a plus 10i. We have minus 4. And again, when we do I times I, that'll make it I squared. Question?
Is there ever a time where they have I squared in the FOIL part?
Okay, same thing as before. You can add or subtract these together. Now, the good thing is when you do this, it's 0i. Which again, if you do 0 times I, that is basically just a 0. So this is 25. That's a 0. Take out the I squared again, replace it with negative 1. So basically, you've got 25 plus 0 plus 4. So that would be just 29. And occasionally, again, on this one, more than likely, if we're just doing regular simplifying, you don't have to worry about putting the 0i. That's usually, you're only going to need that if you're doing some graphing. If we're just adding, subtracting, multiplying, dividing, if the answer is 29, you can leave the answer just as 29 and it should be fine. Shouldn't have to worry about anything else with that one. So again, occasionally some of these, the I variable may go away, or sometimes it may be the whole number may go away, and you may just be left with an answer like this 10i. So, all the answers are possible. It could be that you've got an actual, part like this. It could be you have this. It could be your answer may just be negative 11i. So, depending on how the numbers play out when you multiply out, you could get all kinds of different answers off this thing. Okay, so that's multiplication. Not really, as long as you get the I squared and negative 1 substitution, everything else is pretty straightforward. The good thing about division, which is the next thing we'll do, is that it's really not division. It's really more multiplication. Kind of like when we took, if you take a division of fraction, how we actually wind up turning around and making it multiplication with, keep, change, flip. This one's pretty much the same way. That even though it's a division problem, it's really not division. It's really just a multiplication problem in hiding. So, okay, and here's the catch with the division problem. Kind of like when we were doing square roots, when we went back to that problem when we started doing the trig. You remember that big worksheet we had? We said that you had to go back, and here it was when we did this one. How we had to rationalize the denominator, how we couldn't have the square root with the negative or the squared in the denominator, how we had to get rid of it. Well, when we do complex numbers, they kind of talk about the same thing with these, that it's not, they don't like for you to have the I in the variable, or I have the I in the denominator. So we're going to say we do not want I in the denominator. Okay, and to fix that, we're going to multiply the numerator and the denominator by the, here's a new word we're going to talk about that you may or may not have heard before. If you haven't, we'll get you. Because it's not anything that's too complicated. So to fix that, we're going to multiply the numerator and the denominator by the conjugate of the denominator. Okay, and the conjugate, even though, and again, you may or may not have heard of this. We actually, the problem we did right before this, the last problem we did was actually a conjugate. It didn't have the complex numbers in it, but it was still a conjugate. All that you have to worry about for the conjugate now, if we're talking about imaginary numbers, we'll put it this way. You just change the plus or minus sign basically it's in the middle, but for what we're doing for this part of it, we'll say that's in front of the I term. Okay, so all you do for the conjugate is you're just changing the sign. Now, if you let me go back for just a second to the problem I had back before this, and I'll flash back to it real quick. This one was conjugates because it was 5 plus 2i and 5 minus 2i. So these were what this, if they gave you 5 plus 2i and they said find the conjugate, this would be the conjugate. You just change the sign in front of the I term from a positive to a negative, or if it's negative, you change it from a negative to a positive. And the whole reason that we do that is that anytime you multiply something by the conjugate, the middle term always goes away and you get left with just a number. So now that the I is kind of gone off the bottom. So any of the problems that we're going to do with division, again, they're really not a division problem. They're really multiplication, because all we're doing is we're multiplying by a number to get rid of the I that's in the denominator, and then everything else is okay. All right, so here we go. Let's give you a couple examples on this one. So let's do 3 plus 4i. Have that over 2 minus 5i. Okay, and for the directions, they will tell you to divide and simplify. Which again is misleading because you're not actually going to divide on this one. We're actually going to be doing multiplication to work this thing out to get to what it needs to be. So just realize that even though it says division, we're not going to be doing divisions. It's kind of a trick question here. Okay, so we're going to take the original problem that we have. Now, the one thing is that they don't do that you kind of have to do when you're working this thing out is go ahead and put that original problem with parentheses around it. Okay, and then we're going to multiply by the conjugate, so we're going to make this 2 plus 5i. And whatever we do on the bottom, we're going to do the same thing on the top so that it stays in an equivalent fraction. Okay, and that's all the conjugate is just changing the sign from positive to negative, or in this case, we're changing it from a negative to a positive. Okay, and then once we do that, we're going to do the full method on the top. And then we're going to do the full method on the bottom. And we'll do them in 2 different colors just to make it a little bit easier as we're going through this thing. All right, so on the top, doing the full method, we've got 3 times 2 for 6. 3 times 5i for 15i. 4i times 2 for 8i. And then 4i times 5 would be 20i squared. Okay, and before we do anything with the bottom part, since we've still got a lot of work to do on the top part here, we're going to go ahead and just work this thing out and bring it down here. That way we can just keep working with it till we get it down to a number. We've got the 6. If you go ahead and do 15 plus 8, that is 23i. And again, with the I squared, we're going to take that out and replace it with -1. So it's really 20 times -1, so that would make it a -20. All right, and then one more thing, you've got the 6 minus the 20. So make it a -14 and then plus 23i. Okay, so doing the full method, got it here, had to take out the I squared, had to combine the middle terms, and then once you've taken out the I squared and replaced it, then you got to go back and do a little bit more adding there. So finally get it down to a number, so we finally got it there. All right, bottom part will always be a lot faster because when we do the full method here, the middle two terms should cancel out. So we're really just going to do, we're going to do the full method, but in the middle, we're going to cancel these 2 parts of it out. And that'll make things go a lot quicker. So we're going to do 2 times 2 for 4. 2 times 5i for 10i. We'll do -5i times 2 for a -10i. And then negative 5 times 5 is a negative 25. And again, if we do I times I, that's I squared. Okay, but again, here's the good thing. When you put these two together, they knock each other out. They just go to 0, so that term is out. We replace the I squared with negative 1, so that makes this 4 plus 25. 4 plus 25 is just 29. Okay, now, and if we were doing this problem, it would be okay. Here's where sometimes you have to kind of watch what they do when they're going through these problems, because I'm okay with this answer like this. What they're going to do in the homework, though, is they're going to kind of tell you that sometimes with these fractions, you could simplify. If this was your answer, you have to look to see if you could simplify it. Just like if this was your answer, you'd have to look to simplify it. So basically on this one, what they're going to do is they're going to split this thing up. So they're going to do negative 14 over 29. And then they're going to do 23 over 29. And then if you could simplify either two parts of those, you would. But in this case, that's as far as those will go because they won't simplify. So then that would be your final answer. Okay, so a lot of these fractions, when you see that where you have like multiple parts on the top and just the one number on the bottom, a lot of times they're going to break it up as the first thing over the denominator and then the second thing over the denominator. So that if you do have some simplifying, you could do, you'll go back and do a little bit simplifying there. Okay. Let me give you one more of those. This one's just a little bit different. Sometimes people get freaked out if it looks a little bit different than the ones we've gone through. So let's do 4 over 7 plus I. Okay, still do the same thing. We're going to take that original problem that you have. Again, really think about putting that one in parentheses. This one you don't have to worry about it because it's just the one term, so it doesn't really help a lot. Then we're going to multiply by 7 minus I. Okay, top part, really easy because it's just distributive property. So it's 4 times 7 for 28. 4 times I for a negative 4I. Okay, people go, all right, I like that one. Nice and short. Okay. Now, the bottom part, we're still going to do the full method. But here's the good thing about anytime you do these. The O and the I are going to knock themselves out. So you really don't even have to worry about that part of it. Because, again, if it's a conjugate, these two middle terms always will knock each other out. So it's really just 7 times 7 for 49. And then you've got a positive I times a negative I. That's a negative I squared. And again, you'll take out the I squared and replace it with negative 1. So really it's 49 minus negative 1. So that's 49 plus 1. So that would equal 50. Okay, and that would have been the same. 28 minus 4i would have been on the top, so that would have put us there, just bringing that down. Okay, and again, if this was our answer, or if that was our answer, both of those actually would simplify. So we're going to break it up as to 28 over 50 minus 4i over 50. And since everything is even, we can divide everything by 2. So this one would become 14 over 25. And this would become 2 over 25. Okay, and that's why they always take, if you get just the one number on the bottom, they will make you break it up into pieces so that if the pieces can be simplified, you can go back and simplify the pieces. Okay, so there's adding, subtracting, multiplying, and again, dividing is really not dividing. It's really just a spin-off of multiplication, but a different way of kind of looking at it. Okay. One other thing we got to get to, and we'll see if we can get this part. There's actually a couple other things we have, but we may not have time to get it all in today because I don't know if we can get everything in. So we'll get just as far as we can. But once we've gone through and kind of done everything with this part, we've got the basics, and that's your basics for complex numbers, just add, subtract, multiply, and divide. They start introducing a little bit of solving with these. And we're going to do some solving with this, with complex numbers now. We'll come back and do some solving with it a little bit later. Okay, so what we've got to look at, again, we're going to be solving with complex numbers. Since we're get straight up here. Since we're working with complex numbers with all the imaginary answers, we're going to go ahead and do a little bit of solving. This is the first thing that we'll do is something that you've seen before. The second thing we may wait and kind of come back and talk about it a little bit more a little bit later. But the first thing is you may not like it, but here's what we're going to do. Is they're going to tell you to use the quadratic formula. Yeah, everybody goes, oh, that's great. Oh, I hate that. All right, here's a good thing. Well, I don't know if there's a good thing or not. You don't have to worry about memorizing it. Because, again, it's an online test, so y'all can go back and work on it to kind of get there. The biggest thing is you just need to know how to use it. Okay, so before we do that, here is your quadratic formula. And we're actually going to tweak it just a little bit from what y'all have seen before. Because most everybody's going to use their calculators when they get to this one. We're going to show you how to use your calculator to set this thing up so it's a little bit easier to kind of go through this part. Okay, here's the one little tweak, one little addition I want you to do that you probably haven't done in the past. Every time you've got a variable in here, put just the variable in parentheses. Okay, and if you've got a different color, go back and do that because it's not a big deal. But if you're going to use your calculator, it can be a huge deal in you getting the right answer or getting the wrong answer when it comes off of it. And I'll show you in a second just where that would be. All right, so here we go. Here's example 1. We'll do 3x squared minus x plus 2 equals 0. Okay, and then the one thing I probably didn't mention with this one, we'll go with this one, is that to use the quadratic formula, your equation has to equal 0. So if this thing wasn't equal to 0, you got to move some terms around so that this thing would always equal 0. So that's probably the worst case scenario is that they give you an equation. If it doesn't equal 0, you may have to add or subtract a term or two just to move it around so it would equal 0. All right, and here's what it is. What's with the x squared? The number with x squared is always the a value. The number that's with the x is always the b value. And then the number that's by itself, that is your c value. Okay, so we're going to take this thing, take these 3 numbers and plug it in up here and see what we get. All right, and every time we do this one, I'm going to plug in the numbers in red just so it stands out. So we've got -1 for b. And we got another -1, so it's the same number twice. -4 times a times c. And all that is over 2 times 3. Okay, so just taking the numbers, plug it straight in the formula. And again, it's something small, but putting the A's and the B's and the C's in parentheses can make a huge difference in the end. And I've seen it because people usually there's 2 or 3 mistakes that people make with it. The first thing is people almost always forget about changing the sign on this number if it's negative in the beginning. They go, oh, it's already negative. I don't have to change the sign because it's a negative b up here, so I'm good to go. It's always, basically for this one, the b value will always change because it's minus -1. So it's going to change it to a +1. And people go, every time? Yes, every single time when you do this, the sign of the b term will always just change on that front. If it's negative, you're going to change it to positive. If it was positive, you wind up changing it to a negative. Okay, so that's usually the first thing people miss sometimes. All right, bottom part, let's go ahead and do this because this is easy. It's 2 times 3 is 6. Let's get the easy stuff out of the way. So those are the 2 easy things to do. The rest of this one, and some people are like, I'm not good with the order of operations. Well, you've got a calculator, so let's use your calculator. You can take this thing and plug it back in. I'm going to show you why the parentheses makes a huge difference on this thing. Maybe not a huge difference, but difference in right and wrong. Okay, so it's -1 squared minus 4 times A times C. Do that, you get -23. If you don't put parentheses on that first number, I'm going to show you how to make this answer wrong. There you go. You get a -25. And people go, well, why is that? Well, because if you don't put parentheses around this, because some people don't, because they're like, oh, I remember it's -1, but then they'll just punch it in just like that is on the calculator. If you punch this in, if you take this parentheses off and you just put -1 squared, remember, it's not going to, the negative is separate. So it's doing 1 squared, and it's going to go back and use the negative 1 time. Where when you put the parentheses around it, it's doing -1 times -1. This one is doing 1 times 1, and then it's doing the negative of that answer. So if you're going to use your calculator, and this B number is negative, if you don't put that in parentheses, it's going to count. You're going to miss it every single time. So that's another reason I tell people when you do this, it's small, but put your A's and your B's and your C's in your parentheses, because, and most people do that with these anyway because of the way they are with the numbers. And people this one, but if you will put that B term in parentheses, that will save you almost every error that people make when you go through this thing. All right, now if you were doing this one by hand, this would have been 1 minus 24. But again, that's 1 plus or minus the square root of -23 over 6. Okay, and it should tell you when you're using the quadratic formula, write this answer in terms of I. So now we're going back to what we were doing at the first part of yesterday, that if you have this negative number that's here, we're going to take the negative and replace it and put an I on the outside of the square root. Okay, now if we try to break down 23, 23 will not break down because it's not even, so we can't divide it by 2. 23, you can't divide it by 3, you can't divide it by 5, you can't divide it by 7. If you go back and check it, it's a prime number, so 23, you're not able to break it down, so it's just going to stay that way. If we were doing a paper pencil test, this answer would be fine. And even in the homework, some of the questions in the homework, sometimes there's actually a plus or minus button that's on some of the homework that you'll see at the bottom of the screen. You'll see a plus or minus. You cannot use it on this one. I don't know why. Sometimes they let you use it, sometimes they don't. But in this case, what they're going to have you do is they're going to have to split this thing up. So here's going to be your online answer. Is that one time we're going to do 1 plus the square root, and they actually moved the I in front so that you know that it's separate from, so it's not inside the square root. So one answer is going to be 1 plus I times the square root of 23 over 6. And then the other answer, they're going to use 1 minus over 6. So when you're putting these in online, you're going to have to do it that way. So you're going to have 2 different sets of answers for this thing. One time when you use the plus, the other time when you use the minus, and you're going to have to use the I in the square root of 23. If you happen to leave the I on the end, it might count the answer correct. It might not. I'm not sure on that one. Hopefully, if it did count it wrong, they would say, hey, you got the correct answer. You just have your I variable in the wrong location. They've gotten really good about giving you hints along the way. I know when we first used Math Excel 10 years ago, they didn't give you those hints. It was just wrong. Now they're at least good about saying, okay, you've got it there. You just got to rewrite it a little bit and get it in the correct form. So it is getting better on that part. All right, let's get you one more just to make sure we got a little bit of practice with it. And let me go to the new sheet of paper. I'm afraid this one may run out. Let's do 4x squared minus 7x plus 6 equals 0. Actually, we'll do it this way. So let's say he's got 4x squared minus 7x equals 6. Equals -6. Okay, so this would be one of those problems where if they said use the quadratic formula to solve it, the first thing you would have to do is you've got to move this 6 from the right side back over to the left side. that it's got to equal 0 first. If it doesn't equal 0, you just got to move the terms around till you do get it equal to 0. Usually you just got to add, in this case, just add one term over. Okay, and then once you do that, now you got your A and your B and your C values. Okay, and we're not going to rewrite the quadratic formula because we've got it on the other side of the paper. This time we'll just plug it straight in. So we're going to do minus, and I'll still do the same thing. Every time I plug in one of these numbers, I'm going to put it in parentheses and put it in red. Times A times C. That's all over 2 times A. Okay, let's get the 2 easy things out of the way. You've got a minus a negative again, so that's going to make that a 7. 2 times 4 is 8. Okay, and those 2 things usually should be that easy. You change the sign, and then you multiply by 2. So that part's the easy part. On the middle part, if you use your calculator, I'm fine with that. Just make sure, again, that if the B term is here, especially if it's negative, if you don't put it in parentheses, you will get the wrong answer. It won't be a calculator error. It's going to be an operator error. We can't fix those because, only so much we can do there. It's negative 7 squared. If you're using the Texas Instruments that's similar to the ones we've got up here on the board, do that one real quick because there's not a squared button. Or sometimes there is. You can do it a couple of different ways. We've got negative 7 squared minus 4 times 6. If you do parentheses, negative 7. There actually is a square button there. If you happen to not find it, the rooftop button is also a power button. So if you ever need a different power other than 2, what looks like a rooftop button here, that's your power button. Right below that one on these calculators, there's also the squared, so we can kind of go either way with it. So negative 7 squared minus 4 times 4 times 6. Minus 4 times 4 times 6. Do that, and we get a negative 47. All right, if you were just doing it by hand, this would have been 49 minus 96. But that gets to 47. Okay, if you check 47, it's another one of those prime numbers. You cannot break down 47 as much as you think it possibly could be. So we're going to do 7 plus or minus. And because it's negative, we just have to take the negative out and put an I out here. And again, the way they like to put the I is they actually like to put it in front of the square root. I don't really like it. I'd rather see it at the end of the square root, but that's just the way they do this one. Okay, you can leave it here if we were doing this in class, doing a paper pencil test. But again, we're doing everything online, so we're going to show you the online answer. So we're going to do 1 is 7 plus I times the square root of 47 over 8. The other answer is going to be 7 minus I square root of 47 over 8. Okay, and again, I wish they would let you use the plus minus button. For some reason, they don't let you use it here, but there's actually a time a little bit later coming up. I think it's in the solving we'll do probably next week that you actually can use that plus or minus button. But for now, you just got to do it by hand.